Hello and Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will discuss composite functions with you. So basically, as the name indicates, what we actually do is that we combine two functions or three functions together to get ourselves an overall composite function. This diagram gives you a map of how the composite functions work. So either you can use function f followed by function g individually, or you can just put the domain into the function fg directly. Or even if you want to go backwards, what you could do is that you can first substitute the final range into inverse function g, and then you can put that into the inverse function f to get the original domain. But if you have the overall inverse of fg, then you can directly put this range and get back to the original domain. So you have, again, for forward way, you have two possible ways. You can use function f followed by function g and you will get the range, or you can directly substitute in function fg. And for the backward movement, you have an option of using function g inverse first and then f inverse to get the domain, but you can also do all of that directly into fg inverse. So let's have a look at it with the help of an example. So if you're given a function f which is 2x plus 1 and you're given a function gx which is x square, and you have to find function fg, it's a simple algebraic working where what you have to do is in function f you have to replace x by gx. So in place of x you will replace the function gx, which will be x square, and you will get yourself fgx. Similarly, if you want to find out g f x, so that means in the function g, in place of x, you will replace the function f. So in function g, if you replace the function f, you will get yourself g f x. And there are more examples as well. You could be asked to find out f square. That means you have to put function f back into itself. So in place of x, you would replace 2x plus 1. Or if you have to find out g square x, well, this g square doesn't mean that you have to square the function. What you have to do is you have to put the function g back into the function g. So if you put x square in place of x here, that becomes x to the power 4. You can also perform the composite functions with the inverse functions as well. Like if you find out the inverse function of f, that is going to be x minus 1 upon 2, or if you'll find out the inverse function of g, that's going to be under root of x. So if you have to find f inverse g, in f inverse function in place of x you will substitute the function g. Or if you have to find g inverse f, so that means in g inverse function in place of x you're going to substitute the function f. For example, you can have a look at two examples of functions given. X minus 3 over x plus 1 is function f, and 2x minus 1 over x is function g. If I have to find f inverse, that's like a pretty straightforward thing. Just the way I find out the inverse function, replace fx by y, make x the subject, and then replace x by f inverse x and y by x. And that's what I've done over here to get myself the inverse function. Similarly, I could find out the g inverse in g inverse as well. I'm going to perform the similar working, replace gx by y, make x the subject, replace x by g inverse x and y by x. That's how I found out the f inverse and g inverse. So this is like an old discussion that we've made earlier on. But if I am being asked to find out fg composite function, that means in function f, x is replaced by gx. So wherever you see x, that will be replaced by this whole function, which is 2x minus 1 upon x. So x will become 2x minus 1 upon x in the numerator, minus 3 of the function goes like this, and x again over here is replaced by 2x minus 1 over x. And then I'll do the simplification over here. I'll take the LCM in the numerator and LCM in the denominator. This x and x will cancel out after taking the LCM, and the simplified result comes out to be like this. Do not forget that for these rational functions, they are not defined for such value of domain for which the denominator becomes 0. So please do write down in the end that x cannot be equal to 1 over 3, because that makes denominator 0 and the function infinity. Similarly, I had to find g of x. So in function g, x was replaced by f. So everywhere in function g where I see x, I replace it by the function f, which is x minus 3 over x plus 1, and x minus 3 over x plus 1 here here as well, and then I'll simplify it, take an LCM, and I'll get myself the function g of x. And when I have to find out the function g square, I'm going to put the g function back into the function g. So x will be replaced by 2x minus 1 over x in the numerator, and the x in the denominator would also be replaced by 2x minus 1 over x. So I replace x in the numerator and in the denominator, and I simplify it, and that comes out to be 3x minus 2 over 2x minus 1. Similarly, finally, I have to find f square. That means I'm going to put f back into function f. So in place of x, I'm going to write x minus 3 over x plus 1. And over here also in place of x, I'm going to write down x minus 3 over x plus 1. And I just do my simplification, and I'll get myself the f square x. In some cases, when you have to find out the higher order composite functions, you might be able to read a certain pattern. Like if you look at this question, it definitely seems impossible right in the beginning to keep on finding out up to g15. But when we find g square and we see that that turns out to be x, and then we find g cube, in which we're going to replace x by the function g again, and that comes out to be x upon x minus 1. So I can well see that it is following a cyclic pattern. So every time I'm going to do an even order of the function g, I'm going to get x, and every time I'm going to do an odd order of function g, I'm going to get x over x minus 1. So I can easily predict that g10x must be same as g square x, and that would be equal to x. And g15x would be same as any odd order g cube x, and that would be x upon x minus 1. Also, in some cases, I may have to move backwards, like I know function f and I know function g of x, and I have to find out the function g. So I know that to find the g of x, I would have replaced x by fx. So from g of x, if I have to get gx, that means in place of fx, I'm going to put x back. So if I have to put x back in place of fx, I can see that this form of the function x plus 3 is indicating that this entire thing is the function fx. So if I replace x plus 3 by x, I will be able to get myself the function g. Some cases you might be given functions and you might be given some composite functions, but you would have to find out that what composite function does that represent. And for these kind of questions, you would have to do a bit of a trial and error. And I would suggest you that before you start doing trial and error, also to find out the inverses of the functions. So I have a function f, which is x minus 3. I can see its inverse is going to be x plus 3. And similarly, I have a function gx, and I can see that if I would just perform these steps of finding out the inverse, I'd find out that g inverse is going to be under root of x minus 1. So I will see how can I form x minus 3 whole square plus 1 out of these functions. And then I'll be able to see that if in place of x in function g, if I replace x minus 3, it will become x minus 3 whole square plus 1. So as I said, it's like a bit of a trial and error. You try different possibilities and see what suits you best here. So this part 1 is going to be g of x. Similarly, if you have to find out x square minus 2, so you know that if you have x minus 3 and in place of x, if you replace x square plus 1, it will become x square minus 2. So that means in this case, in function f, you have to substitute function g. So this is fgx. Similarly, if I look at under root of x minus 4, I can like sort of identify that g inverse is the one with the root. So it has to be something putting in g inverse. But how do I make it x minus 4? And soon I'd be able to realize that if this x is replaced by x minus 3, it will become x minus 4. So that means I have to substitute f in g inverse function. So that way I can figure out that this must be g inverse fx. So guys, these are the key concepts you needed to know regarding composite functions. I hope it did help, and if it did help, I'd really appreciate if you'd give a thumbs up and also subscribe to the channel.